Good morning. This is a short video introducing the layout of the KNSG plant. It's currently flowing at around 2 mgd. Here we have used what we call in IViewOps a complex influent. The complex influent has two child assets within it. One is the baseline flow, which is the annual average flow for the last 1 year, and then it has the actual flow. So within it you'll see different controllers. You'll see baseline flow, which brings in an annual average flow condition and an annual average lab condition. It sets the baseline for the plant, relative to which we figure out whether the flow is more concentrated or more diluted on a particular 30-day period or on a particular day. The actual flow has the 30-day average for the current steady state. In the dynamic simulation, we bring in the actual flow data from SCADA or from a scheduler, which is discussed outside of this video. If there are some characteristics of the INI flow component, which is the water going in, that is entered in the INI lab data. The second influencing that you see over here is if haulers are bringing in septage or some other waste. Its characteristics are the average flow, and the lab characteristics of that are entered here. As we go down the hierarchy, what I will do is I will make a little bit more space on the screen. And I will undock this panel over here so that we can see all of the plant. So if you click here, it shows up on the hierarchy. Here is the bar screen. Here is a flow splitter for diversion of high flows to a lagoon, which the plant used in the past. So you can set this controller to divert a certain flow rate. Then you have the vortex grid chamber. Again, if I click on the attributes, the characteristics of the tank, of the grid chamber, etc., will show up here. So for now, let me just keep it docked. Then after that, we have a pump station, and the individual pumps in the raw influent pump station, their attributes are over here. There are 4 pumps, SCADA, or you can drive which pumps are on and which pumps are off through these controllers. The primary effluent comes in. It's colored. The influent before treatment is colored, as you can see, in a grayish black color. The RAS is coming in down here. They have the ability to feed in chemicals here if they want to. So there's a chemical feeder here. You get into what could be switched between an anoxic and anaerobic operation, but they designate it as anoxic A tank. Within the anoxic A, since the plant has 3 trains, you'll see these 3 tanks, each with its own characteristics, the length, width, and then the depth, which is set up, the common depth, 18 feet depth for all the tanks. You will see that through SCADA or manually we set how many of the parallel trains, and therefore the tanks are in operation. There are 2 out of 3 trains in operation at this time. If the nitro recycle is brought in over here, this flow diverter will say which way the nitro recycle is going. When it says 0%, it's this downward leg over here, this T, and there is no flow coming in through here. In fact, if you click on this pipe, you will see that there is no flow coming here. All the recycle flow is going this way, and so it's operating currently in an MLE configuration. This is anoxic B. It has, again, it's 3 sets of tanks. This is a swing zone. A swing zone can be operated aerobically or anoxically. So the aeration system is set up with an on-off controller, and either SCADA, or you can drive whether the air is turned on or off. In the on-off controller, if it is on, the air would be, this value would be 1. If it is off, it would be 0. So both SCADA and you can drive it. IViewOps can be connected to SCADA to replicate what is happening every day if you wish to do it that way. Let's move down to Oxic A. This is the first dedicated Oxic zone. Again, there are 3 trains, and the dimensions of each are here: 34 feet by 50 feet. The depth is 18 feet, as you can see. There are 2 out of 3 trains online. The diffuser system is here. Here is this alpha, etc. The set point controller this data can come in from SCADA or an external file. Right now it's at 1.5 milligrams per liter. And then you have you can run the air on and off if you wish to, or run like in this plant they turn the blower on and off, so the on and off pattern would come in over here. You have Oxic B, which is this next part of the aerobic zone, which is the middle part of the aerobic zone. Then you have Oxic C, which is the downstream end of the aerobic zone where they taper down the air. Then you have another swing zone over here. And then you have the ability to feed in chemicals for supplemental carbon here. And if I now undock this attribute so that you can view the whole screen, if you used a high resolution monitor like an HD monitor, you would be able to view the entire screen without any issues, without having to use the scroll bar. But right now I've undocked it. You have a dedicated second anoxic zone over here. Now, the way the nitrate recycle pumps are set up, hydraulically, some of the flow can come in from the beginning of this, and some of the flow can move through the zone and come out from this side. So we have split the actual nitrate recycle based on how the real hydraulics work to come from 2 locations out through this pump system, through this pumping system back here, and the nitrate recycle pumps are set within these within this internal recycle system. As you can see, there's a nitrate recycle pump group, and you have the pump set up here for each of the basins. Okay. Then you have a reaeration zone over here, which is a small reaeration zone. Then in this version of IViewOps, we can set up the clarifier to be split up to a stilling well, which acts like an anoxic bioreactor. So if the stilling well dimensions are here, there are 2 clarifiers, and so the 2 circular stilling wells, its dimensions are here. Then you have the clarifier system as a whole. Even though we have split the stilling well and shown it externally, it has the underflow specified over here. So let's again look at the attributes, and this is the clarifier underflow system over here. You have the dimensions of the secondary clarifier tanks entered here. So if you click on each of this and go to the attributes, you'll see that it's an 80-foot diameter tank. Its depth, its depth on the attribute is 15 feet. So you have 2 secondary clarifiers. We have separated out the clear liquid section. In this plant, we had to do that because they are cycling the air on and off, and the clear liquid section does act to dampen the ammonia and the nitrate, and you will see that in the other videos. You have a filter over here, and then you have disinfection. Now if you look below, we have the sludge system. You have the wasting over here, the underflow coming here, the sludge wasting, and they waste at a particular time of the day, so that shows up in the dynamic simulation. You have the aerobic digester. and the digester has 4 reactors here. They're operating them in series, and they're decanting from the last one, they're feeding to the first one. So you can set up any configuration for the digester. You have the dewatering system, the press is over here, and you set up what percent of solids are getting removed and all with the dewatering controllers. You have the blowers, and then you can set up these MCRT and HRT calculators for the plant, which you see in the dashboard. Now, the filter backwash, the filtrate from dewatering, etc., are recycled back to the headworks over here. That, in a nutshell, is the setup of IViewOps. We talked about the different scenarios in the other files. So again, I'll pull the attributes back and dock it back over here. So on the left-hand side, you have the hierarchy. In the middle, you have the interface, which is used to set up the plant. As an operator, you don't need to use this much because you have the dashboard. And then you have the attributes. IViewOps 3 has multiple views. You can have a separate view for example, the solids handling versus the liquid treatment versus the headworks. And you can have different monitors in different locations. And so if you have a distributed control system in your plant and different buildings, you can see different views in different buildings.